All right, today we are focusing on calculator questions on the AP exam. Your next test will have calculator in it. Okay, I already got started on this with my class or my in-person class, so let's look at it. The derivative of the function is given by this. That is f prime on this interval, so making sure we're paying attention to that. Where does f have a relative maximum? Okay, just like when we did our sign charts before. When we had an f prime sign chart and we had something like this, we are going to have a maximum. F has a maximum when f prime changes from positive to negative. So on this graph right here, 0 would be the maximum. Okay, that's not the actual information. We were just using that as an example. But we want to know when f prime changes from positive to negative. So we're typing this into our calculator. So let's do that. First thing we check to make sure our calculator's in radians. So we hit the mode button, make sure we're in radians. If we're in radians, we're good. Now we're typing it in. So it says x cubed minus 4 sine x squared sine x squared. Oh my gosh. Fat fingers today, apparently. Sine x squared. Close the parentheses. Plus 1. We type that whole thing in. Okay, when in doubt, we go zoom 6. Is that really the look I want, or the place I want to look? No, it's too big. Okay, it said I want to be on the interval from negative 2.5 to 2.5. So we're going to hit the window button, and I'm going to change my x minimum. My x minimum, I want it to be negative 2.5. And my x maximum, I want to be 2.5. We can hit graph. Now that's a better picture of what's going on. Talk with your neighbor. Based off of that graph, figure out where are the maximums happening. Talk to each other. Let's do it. I'm going to move across the paper. Tell me now when we have reached a maximum. Can you see my cursor? Here we go. So tell me now when I've reached a maximum. Ready? Nah, not that spot. It's going to trick you. You're going to look at that and be like, oh yeah, there's a maximum and there's a maximum. Bad. Okay? That's why we wrote this out beforehand. We said f has a maximum when f prime changes from positive to negative. This is a graph of f prime. So that's what I'm looking for. Tell me now when I have a maximum. No, that's not one either. That is negative to positive because I'm going below to above. So what is this spot right here? That's a minimum. And then that is the spot I care about because f prime goes from above the x-axis to below. That is my maximum. And then what is this spot right here? That's a minimum again because I'm going from negative to positive. So there's only one, and it's between 0 and 1. And so we could do other fancy things. The answer is E. Okay, it's the only one where there's one of them, and my answer is between 0 and 1. If I wanted to calculate it for real, I could go second, calculate the 0. And remember, you got to move the cursor to the left of that spot, hit enter. Move your cursor to the right of that spot, hit enter. It says guess, hit enter again. Oh yeah, 0.542. That is the maximum because f prime changed from positive to negative. Your brain will play tricks on you. That's why we write it out first so we don't allow it to. Questions on the first one? Let's do it again. Now, we're going to talk about motion later on, so don't let this one wear you out too much, but it's a good question. A particle's velocity is defined by this equation right here, between 0 and 2. At which of the following values is the particle slowing down? So they gave me velocity. I'm trying to figure out when I'm slowing down. Let's type it in. So we hit y equals. We clear out what's there. Let's type in the new function. So my new function says sine x cubed minus x. If we just went zoom 6, zoom 6 would be ugly as can be. I definitely don't want to hit zoom 6. I want to change my window. Okay? Because on the problem, it says I'm on the interval from 0 to 2. Change your window from 0 to 2. So window, x minimum 0, x maximum 2. That's still an ugly picture because everything is really scrunched in the middle. So I'm going to go ahead and change my window again. It didn't tell me to do this, but it's going to help me see it better. So I'm going to make my y minimum like -2 and my y maximum +2. And all that's doing is zooming into that a little bit more so we can see it. Everybody good with this picture so far? So here is this graph. I want to know when I'm speeding up and when I'm slowing down in this case. I want to know when is the particle slowing down. What is going to happen on this velocity graph for when I'm slowing down? Closer to 0. If the velocity approaches 0, I'm slowing down. Okay, so let's look at this. We're just trying these out. So 0.255. You might be able to guess okay here. We could do this on our calculator as well. We could go second calculate the value and type in 0.255. The only reason why I'm going to do that is it's going to put an X on my screen where that's happening. At that spot right there, am I speeding up or am I slowing down? I'm speeding up. Okay, right here, I am speeding up because I'm getting further away from 0. This is a graph of velocity. What would you say is true about the velocity right there? Is it positive or negative? My velocity is negative because I'm below the x-axis. What would be true about the acceleration right there? What would I look for on a velocity graph to talk about acceleration? The slope. Is the slope positive or negative right there? Negative. When they're both the same sign, then you're speeding up. That's not the answer I'm looking for. Okay, let's go to the next one, 0.893. So let's figure out where 0.893 is. Second, calculate the value at 0.893. Boom, the X is right there. So that's where I'm looking at. So right here on my screen is 0.893. Right there, what do you think? Am I speeding up or slowing down? Slow down. What is my velocity right there? Negative. What do you think my acceleration is right there? Positive. When velocity and acceleration have different signs, I'm slowing down. Okay, that's the one I want. Okay, I'll just do it quickly. 1.255. Oh, that's like right there. My velocity is positive because I'm above the x-axis. My acceleration is positive because I have positive slope. I'm speeding up. That's not what I want. And then 1.766, that's like right there. My velocity is negative because I'm below the x-axis. My acceleration is negative because I have negative slope. I'm speeding up there as well, so I don't want that. Okay, so B is the one I wanted there. Make sense on that one? Let's go to the next one. Let f be the function. The first derivative is given by that thing right there. F prime is equal to 3 minus 2x minus x squared, and then sine of 2x minus 3. How many relative extrema does f have on that open interval? All right, a couple years ago, I had a student. He missed 0 points all year on every test and quiz. He missed 0 except for this one problem. Okay, so keep that in mind as you look at it. There's something a little bit funky about it. Okay, it's going to cause us to think a little bit deeper. This is f prime. Like always, as we look at this thing, the first thing we're going to identify, what did they give me? They gave me f prime. I want to know relative extrema. Tell your neighbor, what is going to happen on f prime for you to have relative extrema? Talk to each other. Michael, what's going to happen on f prime if f has extrema? Wonderful. The f prime changes signs. Okay, think about that. When we did an f prime sign chart, we were looking for when it changed signs. That's when maximum minimums happened. We're doing the same thing here. Okay, type that in, look at that picture, and talk with your neighbor. How many extrema is this going to have, knowing that it's a little bit funky? Try it out. See what you can do. Go. Let's look real quick. Here we go. So We typed that thing in. I went y equals, I typed it in. I hit zoom 6 just to be a good model of what's going on here. Obviously, that is not what we want. That is way too much information. Okay. In particular here, I want to go between -4 and 2. That's the open interval here. -4 to 2. So let's change that. Window, -4 to 2. Graph that thing. We said it's a relative extrema when f prime changes signs. Show me with your fingers, how many relative extrema does this graph have? Show me with your fingers, how many relative extrema does this graph have? Good. Some of us are seeing it. Some of us are getting stuck there. The answer is 6. Why? This is a mean one. I hate that they put this on the AP exam, but they put it on there. So we got to adjust to it. What do I have to do to find those extrema? What did they do that was mean about this thing? Yeah, this one. These other ones are easy, right? This one, I definitely changed signs. 1, 2, 3, 4. It's this guy right here. And just looking at it at far away, yeah, it kind of looks like it, but it's weird. All right, so I'm going to suggest you change your window. Instead of y minimum of -10 and 10, oh, let's make it -2 and 2. And you can see it a little bit better. Let's get crazy, though. Let's change the window. Instead of -2, let's like make it -0.5 and 0.5. Because all I really care is that it changes signs. I don't care what happens everywhere else. All I'm caring about is that x-axis. How many times did it change signs? Well, there is 1, 2, 3, 4, 5, 6. Okay? There are 6 different extrema on that graph. And the key to that thing was they're being zoomed in. Okay? So if your picture looks kind of funky, zoom it in and it will help us out. Kind of makes sense on that one? Let's give you another example. Let's say you graphed f prime and you had this thing right here. Okay, so we went like that. Okay, let's say you just touched right there. Okay, you just touched at that spot right there. Talk with your neighbor. How many extrema does that graph have? If this is an f prime graph, talk to each other. Aaron, let's go. How many extrema? Show me with your fingers. How many extrema does that thing have? I'm seeing 2 answers, 2 or 3. Talk with your neighbor. Why is it 2 and not 3? Talk with the group. Macy, how many do you think there were? Talk to each other. Jonah, why are there 2 extrema here and not 3? Why is this one right here not an extrema? It doesn't change signs. Good. It's an x-intercept, but it doesn't change signs. Think about if that was on a number line, right? We would go here and it was negative, negative. I drew a bad line. I don't know why I put it below because I never put it below. Negative, negative, positive, negative. I changed signs there and there, but there it goes from negative to being negative again. That is not an extreme. That is not a change in signs. Make sense where that's coming from? All right, let's try another. Okay. The first derivative of a function is given by this thing right here. This is f prime. We want to know, when does x have a local minimum? So again, the whole point of today's lesson is for you to start thinking, what am I looking for before you actually look at the graph? Because if you look at the graph, sometimes it's too late. Your brain has already told you what you're looking for. Write it down. Okay? We want f to have a minimum. F has a minimum when f prime is blank. F prime does what? Everybody show me with your hand, what does a minimum look like? Minimum is this. What is happening with f prime at this minimum right here? F prime means what? Slope. The slope changes. So f prime changes from negative to positive. Go ahead and type that into your calculator. Find that answer. Go. That's what you're looking for. By writing it down first, your brain is going to be better off to find it on your graph. Here we go. It didn't tell me an interval here. Every graph we've done so far has told me an interval. I don't have one. Somebody raise your hand and tell me what would a good interval to be for this one based off of our multiple choice. Raise your hand and tell me. Madison, what do you think? -3 to 3. Why is that? Yeah, so the biggest we're going is 2.5. The smallest we're going is 0. So just something that has both of those numbers and having a little bit of width each side is a good idea as well. So there's not one right answer here. You could have a lot. We want to be a little bit left of 0, so I'm just going to say -1, but you could go as small as you want. And my x max, I'm going to go 3. My y min and max, I think I narrowed them pretty far on that last one, so I'm just going to change it back to like -5 and 5. See if that gives me enough. There's my graph. The question was, when do I have a local minimum? When do I have a local minimum? And again, we already wrote down what we're looking for. We're looking for when f prime changes signs from negative to positive. Tell me now, when does that local minimum happen? Everybody ready? Look at the screen. Tell me now. Ready? There? No. There? There?
Right there.
Right there. Because what are we looking for? F prime changing from negative to positive. That's when it changes from below the x-axis to above. It's that spot right there. It's somewhere between 2 and 3. So we could look at our answers. Oh, it's A. But if I wanted to get correct on that and actually look at that number, remember how to do that. Second, calculate. What thing am I going to calculate here? The 0. I want to find the 0 because I want to know when it crosses the x-axis. So I'm going here. I'm going to the left of it. I'm going to hit enter. I'm going to go to the right of it. I'm going to hit enter. I hit enter again. Oh, yeah, my answer is 2.506 like I thought it was. Everybody good on that one? Let's keep working. A lot of just practice. It's pretty repetitive today, but we're just trying to see some different graphs and some different light and making sure we understand what's going on. This one's a little bit more challenging. Think back to what we did in bell work. There's a reason why we did the bell work we did. The derivative of f is given by this thing right here. F prime is that. How many points of inflection does the graph have on the open interval from -2 to 2? We're talking about a point of inflection. So the first thing we're going to do is write down, what am I looking for? Normally, if I'm talking about a point of inflection, what am I talking about with points of inflection? Second derivative, f double prime changes signs. That's a point of inflection. Talk with your neighbor. If f double prime changes signs, describe to each other, what are you looking for on an f prime graph? Let's do it. F double prime changes signs. Andrew, I want to talk about the derivative. I'm given f prime, and I want to talk about f double prime changing signs. So what are you looking for on that f prime graph? Extrema. Because what happens when extrema happen? The what changes signs? The slope changes signs. Because if I want to talk about a derivative, I want to talk about the slope. The slope changes signs. And we said in bell work, that means extrema. When does the slope change signs? At maximums and minimums. Right there, right there, right there, those types of spots. Type that into your calculator. Find those spots. Go to the screen. Here's the graph you should have gotten. Okay, we should be good at this now. This is our 5th one we've typed in. We should be good at typing it in. We typed it in. This is a graph of f prime. I want to know points of inflection. Show me with your fingers. How many points of inflection does this graph have? How many points of inflection does this graph have? The answer is 5. Because we are looking everywhere it changes, slope changes signs. So a minimum. There's 1 right there. 2 right there. 3 right there because that's a minimum. 4 right there, that's a maximum. 5 right there. This one always plays tricks on kids' minds because they forget about that minimum right there just because it's wide. It's okay. It's still minimum. Still went down to up. The slope changed from negative to positive. That makes it a point of inflection. Okay, so my answer there is 5. Question so far? Let's go to the next one. Try number 6 on your own. I'm not going to tell you anything about it. Okay, we've done a few of these now. Read through number 6, type it into your calculator, see what you can do. Go. They gave me F prime. They gave me F prime. They want to know when F is concave up. So F is concave up. What do we know? Which derivative are we talking about with concavity? Second derivative. So F double prime. F is concave up, means the second derivative needs to be positive. But we're given the first derivative. What am I looking for on F prime if I want to know F double prime is positive? F prime needs to be what? What am I thinking about if I'm looking at F prime and I want to talk about its derivative? I'm looking at slope, right? To talk about something's derivative, I'm looking at the slope. So if I want the slope to be positive, what needs to be happening with F prime? Increasing is the word we're looking for there. Increasing. My screen's going to die. F prime is increasing is what we're looking for. So let's look at that. Let's hit the graph button. I want to know when is F prime increasing. Is that the bell? The answer is A here. Okay, if I look at this graph at the very beginning, I am increasing up until this point right here. So I have to pick one when I'm increasing. It's got to include negative 1.5. That is the one I'm looking for. I don't know why